let's work on some expansions of logarithms. Before we start, I want to make sure that you remember the rules, the product rule, the quotient rule, and the power rule. There is some kind of order of operations that we need to follow when we expand logarithms. And this is first we apply the quotient rule, then we apply the product rule, and last we apply the power rule. So remember this order right here. What I want you also to remember is that if there are roots inside the arguments of the logarithms, then what you need to do is try to simplify them by either distributing, changing the root to a rational exponent, then distribute and simplify. So let's start with this logarithm right here, ln, the natural logarithm, I'm sorry about that, and let's work it out. What's the first thing? The first thing that we see is that there is a root. So let's rewrite this as a logarithm that it has only powers, no roots. So I'm going to change the square root to a power. How do I do that? Remember, in order to do that, I need to remember that if I have a k root of any number, then this is nothing else than x to the 1 over k. So basically, the root, the radical, goes to the denominator of my power. Okay, so right here my k's and my x's look the same, so let me just fix them. Right here you have the k. Okay. So instead of having square root of z, the radical is 2. I'm going to write it as z to the 1/2. Okay, so right now I have what? I have a product of different powers of variables. I don't have any quotient, so I can skip the first step. I'm not going to apply the quotient rule because I don't have any quotient here, any fraction. So I go ahead and I apply the product rule. As you can see, I have a total of 3 products right here, 3 factors right here. So I'm going to split that into 3 logarithms. X to the 3rd plus, the product rule is here, so I'm using a plus, right? The ln of y to the 5th plus ln of z to the 1/2. And I'm done with the product rule. I go ahead and I work now with the power rule. Obviously, I have quite a few powers. I have the 3 on the first term, the 5 on the second term, the 1/2 on the third term. And I need to bring them down using the power rule. So what I will have now is 3 ln of x plus 5 ln of y plus 1/2 ln of z. Okay, and that's my answer for this problem. This is my final answer, because this problem, the only thing that I wanted to do was basically to expand the logarithm into a sum of and difference of different logarithms. So that's it, that's my answer. Let's work with the second problem, and the second problem here tell me it's again a natural logarithm, and I have a square root. So I'm going to work with the square root first, and I'm going to rewrite it as ln of inside the argument. Remember, parentheses or brackets, square brackets, curly brackets is the same thing. It doesn't change anything to my argument. Now I have the square root here that it is applied to a fraction. So what I need to do is change it as y over z to the 1/2, but the entire fraction is to the 1/2. So the next step is to simplify this, right? Using again rules of exponents here. So I want to remind you that when you have, let's say, x over y to the k, That's another rule of exponents that is helpful. It's really helpful to remember. You can always distribute the power, the exponent, to each one of the numerators and denominators. And this is what I'm going to do here. I'm going to split my fraction inside without touching the argument. I will continue, x is here, but now I have y to the 1/2 divided by z to the 1/2. Well, at this point, I can do two things. The first thing is to actually work with the fraction and multiply this fraction with x. As you can see right here, we have a product. Or we may look at this problem as a product of x and move the x at the numerator. No matter what you're gonna decide to perform first, the result will be the same. So what I will do is I want to follow my priority of operations here. So I want first to finish with the quotient rule and then move on to the product rule. And in order to do that, what I will do is first I'm going to multiply the x and move it at the numerator. As you know, when you have a fraction, then the multiplied by a number or a variable, then the multiplication stands as follows. If you have a times b over c, then this is the same as if you have a times b over c. So this is what I apply here, and the result for this will give me ln of, now I can apply the quotient rule, ln of x times y to the 1/2 minus ln of z to the 1/2. So at this point I can continue with the product rule, and I will apply the product rule in the first term right here in order to finish it, and I will have ln of x plus y, ln of y to the 1/2 minus ln of z to the 1/2. And now that I have three terms, the first term is done, is ready. There is nothing else that I can do to simplify it further, ln of x. But the second one has power, it has an exponent, so using the power rule I can bring the exponent down, and I can have 1/2 of ln of y minus, the same thing happens here, 1/2 of ln of z. And this will be my final solution for this problem. As you can see, you really need to apply what you know about the fractions on monomials and have the power rules, the rules of rational exponents, the rules of exponents in general. So algebra, overall, it is very important to know all your rules and apply them here in order to come up with the final results. So let's work on one more problem that I have here for you. Log of x times the third root of y squared divided by z to the fifth. So I will simplify first of all the root. This root is a third order root. So this will change, and I will have x to the second to the 1/3. So I'm going to change the radical right here, and I will change it into a rational exponent, and this will go to the denominator of the exponent, as you can see, divided by z to the fifth. And now I can also simplify the power that I have, y to the second to the 1/3 We know that when we have an exponent raised to another exponent, I should multiply those exponents. So I have x times y to the 2/3. 2 times 1/3 is 2/3, divided by z to the 5th. Now this is more clean, and I can apply my quotient rule. So I can separate the numerator from the denominator using the quotient rule. Log of x times y to the 2/3 minus log of z to the 5th. Now I can apply the product rule for the first term to the first term, and I have log of x plus log of y to the 2/3 minus log z to the 5th. I still have exponents, so I can apply my power rule, and I will have equals to log of x. The first one stays as is, because as you can see, how do you know when to stop? You should look at your argument. If the argument has just one variable in it, then you're done. You have expanded as far as possible. Plus 2/3, so I bring the exponents down using the power rule. Log of y minus 5 times log of z. And this will be the final answer for the third problem that I worked at right here, to expand this single logarithm that I started with into sum and difference of 3 different logarithms here.